Hello everyone, this is our science teacher Tim Martin, and in this video I want to discuss lunar eclipses. Below you can see several images that I took during a lunar eclipse. There's a lot we can learn when the moon passes into the Earth's shadow. In fact, this very idea of the moon passing into the Earth's shadow is what led Pythagoras, Aristotle, and several other ancient Greeks to the understanding that the Earth was spherical. They knew that a lunar eclipse happened when the moon passed into the Earth's shadow. They also knew that the only shape to consistently cause a round shadow was a sphere. Thus, 2,500 years ago, they were able to determine that the Earth was spherical. Here's a diagram that shows a tiny moon orbiting a small Earth. The larger dotted line indicates the Earth's orbit around the Sun. This diagram is to scale. Unfortunately, I don't have the Sun indicated because the Sun's distance is 400 times greater than the distance between the Earth and the Moon. In this very similar diagram, I have highlighted the plane that the Moon is orbiting the Earth. You may notice that the plane is slightly tilted from the perspective of the Sun-Earth alignment. This helps explain why we don't have an eclipse every full moon. Frequently, when the moon is on the opposite side of the Earth from the Sun, it is slightly above or slightly below the Earth's shadow due to the 5-degree tilt between the planes. There are two special spots in the Earth's orbit around the Sun where the planes align. If, during one of these alignment phases, the moon passes on the opposite side of the Earth, it may pass into the Earth's shadow, creating a lunar eclipse. Let's take a closer look at this scenario when the moon passes into the Earth's shadow. You'll notice that this diagram is no longer to scale. The Sun is depicted on the left with the moon and the Earth on the right. Notice that the moon is in the Earth's shadow. You may also notice that the shadow is complex. There is the penumbra, or partial shadow, and the umbra, or the complete shadow. If an observer was standing in the umbra, none of the light source would be visible. In the penumbra, part of the light source would be visible. It's worth noting at this point that unlike a solar eclipse, anyone on the nighttime side of the Earth can view a lunar eclipse. It's also worth noting that during a solar eclipse, the observer looks towards the light source, and during a lunar eclipse, the observer looks away from the light source towards the shadow. Here's a perspective of a lunar eclipse as viewed from above the North Pole. The moon is orbiting the Earth. At first, the moon enters the penumbra, then it enters the umbra, becoming totally eclipsed. It exits the umbra into the penumbra, and then eventually exits the penumbra, becoming fully illuminated once again. Here's an animation that shows a lunar eclipse as viewed from Earth. At first, the full moon may show just a slight dimming on one side. The dimming increases as the moon enters deeper into the penumbra. Eventually, the moon will appear to have a bite taken out of it as it enters the Earth's umbra, or complete shadow. Once the moon fully enters the Earth's umbra, it is totally eclipsed. It often takes on a reddish color. After more than an hour in the umbra, the moon may begin to emerge on the opposite side. Again, appearing as though a bite is taken out from the moon, it still may be dim on one side as it is still in the penumbra. Eventually, it will become fully illuminated once again. Here are a couple images that were taken during a penumbra lunar eclipse in February of 2017. The image on the left shows what the moon looked like before the eclipse started. Then, as the moon passed into only the edge of the Earth's penumbra shadow, the northern edge of the moon was slightly dimmed. In this sequence of images from an eclipse in 2003, you'll notice the moon entering the Earth's umbra. This, in fact, was a total lunar eclipse. As we look at the images towards the bottom of the page, you'll notice the reddening of the moon. This telescopic view of the moon during an eclipse highlights the red colors that are often visible when the moon enters the Earth's umbra shadow. Why the red colors? As the moon enters the umbra, sunset colors from around the edge of the Earth filter through the Earth's atmosphere, and those sunset colors show as red or orange on the surface of the moon. How bright the colors are is frequently a proxy indicating the clarity of the Earth's atmosphere. During totality, the moon may appear much brighter if the atmosphere is clear. I'll always remember the darkest eclipse I've ever seen shortly after the eruption of Mount Pinatubo. The considerable amount of dust produced by this volcanic eruption caused lunar eclipses to be much dimmer over the next several years. This is Greensboro Day School's Earth Science teacher Tim Martin, and I would love to see you under the light of the next eclipsed moon.